Well, hello, everyone. Can you all hear me? I can hear me. Wow.
Hello, hello.
Hey. Thanks for staying over dinner time here. Please don't be hangry. I'm Mads Torgersen. I'm an architect at Microsoft, and I dabble in C# design.
And my name's Dustin Campbell. I am also an architect at Microsoft, and I also dabble in C# design and tooling.
And this is the extent of our slides because you're not here to hear about us or anything like that. We just want to go and do some coding.
Yeah.
So how we're going to go about this today is most of the C# 14 features that we planned are actually in preview right now, like if you're using the latest stable bits.
Yeah. In fact, what we have installed here is the whatever latest release of Visual Studio 17.14 that released last week. And so the stuff we're going to show in Visual Studio is all bits you can get either out of the Visual Studio preview channel or in release. So these language features are there so long as you set lang version preview.
So you can go and play with exactly the same bits we have here
Yeah.
for the most part. And then towards the end, there's a couple of features that we have like hot bits for that may or may not make it into C# 14. They're sort of like in decreasing order of likelihood, but they may all make it in. But we'll show them to you and just, with those caveats. And we'll show those actually in Visual Studio Code and with C# Dev Kit. If they come out in preview, that's probably where they'll show up first. And just also to remind you all that actually C# is pretty great in VS Code as well.
Yeah.
So when we switch to VS Code, that's when you know we're in dangerous territory in terms of will these features make it into C# 14?
Yeah, don't count on these. Don't tell your boss. We're going to start using these. They're going to be amazing. It's going to change the whole code base. Don't do that with the ones in Dev Kit.
Right.
So yeah.
So we're going to start small. Can you see the code? Is that fine? All right, good. So what we have here is in C# 13, which is the one that's currently out. It gets hard to keep track of. But we're in C# 13. And we just have some code that has several nuisances in it, and we're going to make it better.
We just want to make them better. There's a lot of things about C# that every release we just try and make a little nicer, right? Just so that you guys can feel better about your day and take out little bits of boilerplate and things that just seemed so important at the time sometimes when we were designing them to do in a certain way and then realize that, in hindsight, maybe it would have been better to do it this way in the first place. So
while we've been talking, that green squiggle has been bothering you, right?
Yeah, this one?
Yes.
Everybody here has got a little something or other. Yeah, that's got them that they're just annoyed by that. Yeah.
But it's great. It's nullable reference types analysis telling us we have a bug, right? We're dotting off something that it says loud and clear, if available. It might not be there. It might be null.
Yeah. And so to fix that, this is nullable analysis, right? Everybody's seen this in C#, since C# 8, actually. And so to get rid of that, we're going to have to do our null check here. And and there that fixes that and moves the warning nicely for us, making sure that, the video game that I'm playing right now is still active as I missed it. Trying to whack-a-mole that thing.
Yeah, because now there's another warning came up there.
Yeah.
So isn't there a better way to do it? Didn't we do the...
We do have a better way. I know the better way.
We did a feature for this, right?
We did a feature for this. It's called the null forgiveness operator, right? So I can just put there. Whoops, I can put an exclamation point right here, and that just makes all the warnings go away, right?
Yeah, just make the warning go away, and then you have no bug.
The bug's gone. Nothing to see here is the name of this operator. Yeah. Nothing to see here.
It's interesting that several releases before we actually had nullable reference types. We added a feature for better null actually. It's a question mark dot, right? But it doesn't work in assignments, right? It only works when you're on the right-hand side.
No, it's actually really annoying. We took the time in C# 8 to make an exclamation point available here, but didn't make a question mark available here, right? So this doesn't work, and it stinks.
Yeah,
right?
that would be really cool.
If I could just shortcut that.
Yes. And what's the red squiggle there?
Oh, that red squiggle's telling me that if I upgrade this to the language version preview, it will work. And so I'll go ahead and do that. That's updated the project file, changed the language version, and now this feature does work, and it's null conditional assignment.
Sounds like we're doing good here. And so just to make it clear, what does this do? It does a null check, obviously, before it does anything else. And then if person there is null, then it doesn't do anything else, right? It doesn't evaluate the right-hand side. It doesn't do the assignment. It doesn't access the property or anything like that, right? So everything in that assignment is guarded by the null check.
And I think at the time, right, if I think back to C#6, which seems like forever ago, but if I think back, I remember actually talking about some of these scenarios and thinking, well, this might actually make the control flow confusing, that like, okay, you could have all these dots in a row and then some questions in there, and it might short circuit a whole bunch of code that you think ran. And I think we've just gotten comfortable with it since. It's been years.
What do you say? If you think this is really confusing and we shouldn't do it, shout boo.
Okay, cool. We're good. Okay. But that also means that down here, I can shut this warning up by doing the same thing, just putting a null check in.
Yes.
And the compiler does this very, very efficiently.
So yeah, properties, events, it'll work on all of those.
Yeah.
So what else?
Well, there's a couple other nuisances here. It's a nuisance that you wrote an event that has an out parameter at all.
Yeah, I'm sorry, I had to come up with something.
But one of the nuisances, I mean, when you're writing a Lambda expression, one of the nuisances is that whenever you need to do anything, like add a modifier or whatever, it's like, no, you got to do everything. Sorry. Once you do that, now you have to specify the type. You can't be type inferred, And so in this case, it would be really nice if we could have just said name and out success, but we have to say the types.
There's a long form and a short form, and I'm sorry, but you're in the long form scenario.
Yeah. And it's just annoying. And so, we're making that not a thing. There's, in fact, a nice little fix for it. They'll tell me that we're not going to make that a thing anymore with a little diff, and I can go ahead and accept that. And there we go.
It's a tiny little thing, but we got to cut those corners anyway.
Yeah.
Not applause-worthy, apparently, but it's still, hopefully nice. Okay,
all right.
we're good.
We're good.
So there's some partial, let's go look at that person class. That's a partial, like the scenario here, assume that the way we're thinking about it is there's sort of like the user-defined code, like what we use partial classes for often nowadays. There's a user-defined code, and then there's some, maybe a source generator produces an implementation of some things. And an example in there, there's a partial method in there called name changed, that we just do the definition there, and we're sort of telling the source generator, please implement this.
This is actually really interesting because, when we introduced partial methods in C#3, it was actually the other way around a lot of the time, right? It was like you were going to provide an implementation to the code generator, and it was going to call the partial methods as like extension points, and you could implement those extension points, and that's kind of what they were for.
Yeah.
But with source generators, we have this much more sophisticated mechanism. It's almost a two-way street because the source generator can analyze your code and see that actually you've provided a declaration that it should provide an implementation for, or vice versa. And so it's kind of one of the things that's made source generators really interesting, and why we're adding more of these support.
So in C#13, we added support for partial properties and partial indexes, and that's kind of how far we got. But there's an event on here, and it's only, we would really like to do the same with the event, like just be able to specify the event in the user-defined class, and then have the, like this source generator, maybe what it's for is implement your eventing, right? And you just want to
maybe you just define partial events, and it goes in and says, oh, well, let me fill this in with the machinery. That would be very cool. So I can just call this partial. This is, however, on the implementation side, the error I'm getting will tell me that, you need to put on the definition too. So I'll just take that, copy it over there, and give it a semicolon. So now it's a partial definition, and now we're good.
Yeah, and we do constructors as well this time around, so we're kind of getting around to all the member kinds, and you can do them all partial. And hopefully that's a little helpful.
Absolutely.
I noticed some like mangly stuff down there. On name changed implementation. There's some name of stuff.
It's funny. This goes back to C#6 as well, right?
Yeah.
This is a name of a generic type. Has anybody run into this where like when you want to do a name of a generic type, you've got to put something in the arguments to make it happy? Like the compiler is like sad and needs to be made happy if you don't do that. And it's really, but you don't have to do that with type of, just name of.
And the most ironic thing here is that the string it produces doesn't include the type argument.
It doesn't matter what I put in there. I could put
whatever.
I could put this in there.
Says change handler.
Yeah. So it's kind of a silly thing. And it's another one of those, it goes back to C#6 again, right?
We were a little busy.
We're very busy.
Yeah, we were implementing
Very
a new
busy.
compiler as well. So
And yeah, and this was one of those moments where like we can get this feature, but we need to cut some corners.
yeah.
And, and that was the corner. We couldn't like make it an unbound generic. And
Eight versions later, here we are.
8 versions later, you are welcome
Oh my God, look at that.
at Bug Fix.
Beautiful.
People clap for bug fixes.
Yeah.
We even took the time. I didn't use it, but we even took the time to like just to give you a little code fix for it as well. So yeah,
Okay.
cool.
Those were like little features, right?
Yeah.
Let's do something that's a little more impactful. I think we're ready to talk about fields, right?
Yes.
Yes.
Okay.
So this is a feature we talked about for some years, and it's finally going in now. Knock on wood.
It's in. I'm demoing it in
Yeah,
the product.
it is in. So the situation you have here is pretty common, right? You have maybe you wanted to write an auto property, but you had to do just one little extra thing in the setter, like trigger an event or trim off the white space or whatever. And now you fall off the cliff, and you have to like write the whole. I could be more animated.
That was the best depiction of the cliff
right?
I've ever heard.
And you have to write the whole thing manually. Like you just auto props are out, and we want to remove that cliff.
Yeah. And so removing that cliff means getting rid of, the cliff is the field, right? That's what we call the cliff. Whenever you're writing an auto property and suddenly you got to drop down to the field, whatever is making it happen. It might be any number of reasons, but that's the cliff, and because it's a pain.
Yeah.
But I can remove that field. Now I've got 2 errors here. I can
The getter is
take that
fine as
body
an-
off.
Yeah, it's an auto
And
property.
this is, yeah, it's an auto property, so I can access it now with the field keyword, right? It's still an auto property.
Yeah, it still generates a backing field for you. If there's a body missing, like in the getter, or if the field keyword is used, then it generates a backing field for you, and you access it using the field keyword. But it's not called field, and so other members can access it. So it's both like your code gets shorter and nicer, but it's also you get that kind of, I guess it's not encapsulation, but hiding.
Yeah.
So that other members don't accidentally access the field instead of the property.
It's a little contrived. I probably wouldn't do this since there's like multiple statements on the line, but this is even now like a one-liner, right?
It's kind of neat now.
Yeah, that's all right.
Now you're totally welcome to implement both of the accessors. It's not that one has to be empty. And
we could very easily do this, but it's kind of redundant, right? It's an auto property. It's
Yeah.
still an auto property if I have both, if they're just accessing field as their backing field, right?
Yeah.
So if they have the field keyword. So it's still an auto property. We kind of made it very fuzzy now as to by looking at it, if it's an auto property or not.
The auto means that it generates a backing field now.
Yeah. So you
Okay.
don't have to manage those 2 pieces of data, and you can encapsulate that nicely, or data hide it, as you said. Yeah.
So that hopefully is helpful. There's a little niggle that we have to talk about, which is that when you actually do implement them both, this is actually legal C# syntax today. There could be something called field in scope.
You could have had, have had this, right?
So there is a little bit of a language breaking change here that we have to own up to, which is that field changed its meaning from referencing an existing thing to now being a keyword in its own right, a contextual keyword saying right here it means the generated thing.
And it's so easy to think like, oh, but who uses that for a name? And this is, but it's databases, it's domains like academia for fields of study, or agriculture or what,
physics.
Like, we had the same problem when we tried to use,
fields.
It turned out the financial industry was not really keen on us using yield as a keyword by itself either, right? Like there's a lot of domains that take these words. So
So it is a bit of a language breaking change. So when there's something in scope called field, we do give you a warning saying if this code was here before, it now means something different.
Yeah.
And we don't have fixes right now yet in this implementation, I believe.
Not yet, I think.
But you can, we will have like fixes when this ships, but there are a couple ways that you can fix it up, right? You can either, like you did with the @ there, you can say, like with any keyword, you can turn it into an identifier by putting @ in front, or you can just say this.field, like you do with this.value sometimes. If value, did you know about, like if you have something called value, you want to get at it from a setter, and the value.
This value right here, this one
variable
right
gets
here,
in
the
the
one
way,
that's implicit inside
you'll
of
say this.value instead.
of a property setter.
We can do the same thing here.
Yeah.
So that's how you kind of get around it. And you may have, if you're using field, lowercase field like that, you may have to do a little fixing up. And hopefully that's not too big of a problem, but we'll find out.
And I realize that in previous talks we have shown this before, but it's always been like, and we swear it'll be there. It's actually here. We're using the release bit, so it's actually there today. Okay, so it's underlying version preview, but it is in the product.
Famous last words.
Famous last words, and then Jared removes it. Thanks, Jared. Jared's down here. You guys can make sure he doesn't remove it later.
Okay, let's now for something different.
Yeah, let's step over to a different. Actually, I don't have a different Visual Studio up. Let's just
Switch over in there. We're going to talk about extension members.
Yeah. This went well. This is good.
When was it? C# 3? That was
It was
2008.
2008.
We
so
shipped extension methods.
17 years ago.
And then people immediately said, hey, that's great. When do we get extension properties? When can I make my extension methods static? You know, and we're like, oh, we'll go work on that. And then it turned out to be really hard. And we can sort of, so what we have here, and so just spoiler alert, we're doing it now. What we're looking at here, this example here is we just took a couple of the methods from System Link Enumerable and we just copied them over. Didn't actually copy the implementations just because they're long. But just to use them as examples of what we're doing here. But let's talk about why we didn't add something like extension properties before. And it really has a lot to do with the syntax that we chose for declaring extension methods. Right, so you got one here. It needs to be able to express a receiver
That's the first parameter.
The first parameter.
Yeah.
When you look at the call actually up on line
Yeah.
3, right? An extension method pretends it's an instance method on its receiver.
It's like in Costume. It's like playing as an instance member.
First here is saying, I'm an instance method with 0 parameters. But it really is a static method with 1 parameter, that is the receiver parameter. And actually, it also has a type parameter, making sure that it's generic and it applies to all enumerables through generics. So being able to specify it like that works well for methods because methods do have parameters, so we can slap an extra one on there, and they do have type parameters, so we can also put an extra type parameter on there, whatever type parameters we need.
Properties have neither of those things.
Yeah.
Yeah.
Syntactic cliff.
Yeah.
And we've tried so many things over the years, and now we think we figured it out.
Yeah, we do.
So essentially, the trick is take all that, in order to allow other member kinds, take all the stuff that is method specific here.
Yeah, so like the generic type parameters and the receiver parameter.
And the receiver parameter.
So we just take those.
Yank it out to a separate scope that we put that on, and just put extension members inside of that scope. Now the members themselves don't have to specify any of that stuff.
Yeah.
So let's.
We can clean this up a little bit too, because we don't need the this keyword any longer, because it's in a thing called an extension. We know what it is. We know that's a receiver. That's special up there. That's kind of the blessed receiver parameter. This is redundant. It already has a type parameter up there called tsource, and this method will also get that. And of course, we're already declaring the receiver parameter up there. There we go. And so we're good, right?
It's getting pretty close, but we're getting close to what it's pretending to be. But it's pretending to be an instance method.
Yes.
So we should remove the static as well.
Yeah, and so we'll take that off, and now
it looks exactly as if you declared the member it's pretending to be.
Yeah.
Right? That is the actual member syntax you would have written if it was an instance method.
Yeah. We call this the reduced form with an extension method.
Yeah.
This is the thing it reduces to, and then there's the regular form, which is calling it as a static method.
Right.
So.
And you can kind of squint now and see, oh, now I probably get how they can add other member kinds. But we're going to keep you in suspense for a little longer while we examine how this actually works for the methods.
Yeah. So we got the parameter up here, the receiver parameter, and it's important to be here because we do have other things we can do with this, right? And so we want it to look like a parameter.
Yeah, like one design choice we could have had is where it says in the body there in the implementation where it says source, we could have used this keyword, so it looks more like so it looks more like an instance method.
On that first parameter, but we call that first parameter this.
Yeah, but we decided to keep the parameter syntax for that like we have in the old extension methods. because it's actually useful to treat it as a parameter. Sometimes you want to maybe have a
do
modifier
ref,
on there.
Yeah, you could do ref. You could put, any of these things. You could put attributes on it.
Yeah.
Right. You could make it nullable. Right. That's something that you can do with a receiver parameter as well. And sure enough, now we get a nullable warning.
And this is not theoretical. Like when we designed this feature, we looked at many extension methods in the wild, not just our own, but on GitHub and so on. And a lot of these things, like this expressiveness really gets used. So we're like, yeah, we're keeping these as parameters. That's clearly useful to a lot of people.
Yeah. But with an extension method in this new kind of extension block syntax, as we call it, we wanted to make sure that there was significant compatibility, right, with the extension methods you got. And frankly, sometimes it's easier to just write a regular old extension method. They're not going anywhere. It's really easy to add this to an existing static method and make it an extension method if that's what you're doing.
And you have a lot of consuming code. So we wanted to make it so that you can port from the old syntax to the new syntax if you want without breaking your consumers. But that means, one thing that means is like when you have an extension method and you want to call it, but it's kind of ambiguous with another extension method, or maybe it's shadowed by an instance method that got added later or something. The disambiguation syntax today for extension method is I just call it as a static method.
Right.
And that has to continue to work. Does it work?
It does work. It works perfectly.
Yeah.
And there it is, and we see exactly the same hover quick info tip. And so this works exactly the same as it did before.
Yeah, because when we see that new syntax, we generate the old extension method for you as well on the static class that this is all in.
Yeah. Something to we call it an extension block, almost because it's not really a thing. It's not a thing that's there. It's almost like a holder, right? Yeah. I think you described it earlier to me as like, it's the thing that we take all the things that make a method, an extension method, an extension method, and we just lift them up. All the things that are very methody, the generic type parameters, the receiver parameter, and we just lift them up into this, this block. And now they can be available to everything inside of it. So right now it's like, wow, you just made a really wordy way to write an extension method. Great job, guys. I can put more in there, which we should do.
But yeah, just to the second call of first up there.
Yeah.
We generate that static method. It's actually even an extension method in the old sense. So if other older compilers or other languages consume the output of this, they will still see an old style extension method. That it is really there in metadata still.
Right.
That's how compatible we make sure to be.
Yes. Let's go ahead and move another one up.
Yeah.
Because it is a little contrived to have one in there. The first thing you ask for is, well, that seems really wordy, right? So we'll do the same thing. I'm taking select here. Okay, select, we know it doesn't need to be static, right? We can take that off. It's going to look like it's reduced form. Therefore, I can remove the t source. I'm going to leave the t result, though, okay? And I can take off the receiver parameter, and there we are.
I'd leave the other parameter. So that's just a slightly more complex example where some of the parameters move up and some of them stay.
Yeah, and it's interesting because some of these are like, if I go to like my enumerable again, I can see select is there, and if you look at it, it's joined together both those type parameters because it really is just a construct that just here's the stuff that goes to everything, right? And so it's still the same method that would have been written before with two parameters, and so it works the same. If I do numbers dot select down here and I get the one off of my enumerable, it's the same thing with the same stuff. So,
yep.
Yeah.
But you didn't come here to see us reinvent extension methods. We already have those.
But as we said, you can see, I hope you can see how it will be possible to add other member types in here now.
So let's actually, it's time, right?
I suppose.
Let's change the first method, extension method, into an extension property.
Okay. So how do I make a method a property? I take off the parameters and I add a get, right? And there we go. That's done. Now, interestingly, there's an error here because there is no longer a first method on my enumerable. There's no error here because now it's dropped back to the actual IEnumerable one.
Yeah, we didn't take the link once out.
I didn't take that away. But I can remove the parameters here. And sure enough,
we're calling it as a property.
We're calling it as a property.
Your first extension property, ladies and gentlemen, appropriately called first.
Ah.
And it's a real property. You could add a setter if you want to.
Sure, that would be cool.
let's do a dummy one. 'Cause
Yeah, I mean, it's a little weird because one of the things about extensions, these are very, under the hood, they are static things. And so we are not planning on introducing state into these things or instance fields. So you can't have, say, an auto property because there's nowhere to declare a backing field. You can't declare it on this object that just came into you.
There'll be
right?
no extension fields,
So-
no extension auto properties, and no extension field-like events, because they all declare state, and we're not going to add state to somebody else's object.
But if you can have, if you have a table on the side, you have things you want to do with that, and your API is such that a set makes sense here, then that is available to you as an API shape.
You do get to do it.
And I think that's kind of one of the powerful things about extension methods, and now also extension properties and other whatever else we bring here, is that this gives you the ability to have an API that is discoverable when you press dot off of whatever that thing is. It could be an instance, a reference to an instance of some class. It could be that you've got extension methods for, and you can just dot into that and get the API shape that you're looking for. I think it's super cool.
So that, and you can see now that we have having the extension blocks, it gives us a scheme for adding any kind of function members as extension something.
Yeah.
We're not adding all of them at this point. We're starting with methods and properties, and we'll also see static versions of those in a bit.
How would we disambiguate this?
Yeah, so that's a good point. What is disambiguation?
This is one of the
look like
problems
here?
we've had too.
Yeah.
It's one of those niggling problems is that methods have this wonderful disambiguation syntax that's automatically there. It's just a static method call. But what do I do with this? Right? It's a property. How do I?
Let's go and
Yeah.
hit dot.
Well, let's delete the comment
Ask
first.
the
Let's ask IntelliSense.
ask IntelliSense.
Yeah. Well, it turns out that first is here and available to us. And what the compiler has done is it's generated the two methods that actually make up every property that you write that has, for the accessors, right? It introduces get for that get accessor and a set underscore method for that set accessor. These are things that we don't let you write today because we reserve them for properties. It's an error if you try to write one of these by yourself, say get underscore something or set underscore, because we reserve that space for properties. And we still reserve it for properties. You still can't write these here.
Except,
You can't declare them, but
that's true.
we allow you to call them to disambiguate.
When they're extension properties, we put these methods out because that's much easier. Any actual dedicated disambiguation syntax we could come up with was at least as ugly as that. So we're just going to give you the sort of built-in ugly.
They were less ugly, but they had weirdness. They all had weirdness.
There's something to learn, right? And here you just go press dot, and you got get first. Yeah, okay.
Just wait till we do operators. They'll get ugly.
See what it does.
Yeah. And so I can now call this, and I can pass in my receiver parameter because I've turned it into a method, and that method has the t source parameter on it. So it works like that.
Yeah. So
That's how we disambiguate properties. So finally we get to do this. Hopefully it's not very common. Hopefully. But it comes up, right? It absolutely.
Oh, the disambiguation?
Yeah, it does come up.
It's a thing that you occasionally need to do, and then it's good to know there's a way to do it, but we don't expect it to be common enough that you have to litter your code with get this and set that. So.
Cool.
Right?
All
and
right.
if we're wrong about that, we can add a syntax later. We just didn't yet because we don't think we're going to need it.
Yeah.
So we'll see.
What do you think?
Okay, so far?
Yeah. Everybody just wanted to add, enumerable.count all these years as a property.
Yeah.
Probably the worst thing to add as a property, by the way, because it's going to be expensive. But now we can.
Now you can if you really want to.
Please don't. Is empty might be better.
Yeah, that's a good one.
Yeah. All right.
Yeah, is empty is a brilliant property to add. Yes, you should do that.
Yeah.
We should do that, actually.
We should. Tanner Gooding, who's sitting right over there from the runtime, should do that.
When are we going to get is empty as an extension property? Come on, this feature has been in for weeks. What's that?
As soon as somebody writes an API proposal, he said.
Okay, yeah. You heard it? You heard it from the
You heard Tanner volunteer to write an API proposal. That's what I heard.
Oh, that's
all
right. Okay, there's one more thing we pulled over from the system link enumerable type, which is that range method.
Yeah.
And it's it's not actually an extension method. It never was. It's just a static method, like a helper method, that just sort of like sits there on that type.
Yeah.
But you kind of have to go look for it to realize it's there. It's not very discoverable.
Yeah. Again, extension methods are great for being discoverable and
Yeah.
that one you got to know.
It's not an extension
Yeah.
method because it's not on anything.
We could make it an extension method.
Yes, a static extension method.
Yeah. So like if we're talking about IEnumerable, we could again declare extension block, right?
So just to be clear, what we want to try, how would you make this more discoverable?
Yeah.
Well, stick it on somewhere where people would look. So why
Yeah.
don't we stick it on the type that, it's a factory. It's a factory for IEnumerable events.
Exactly.
Right? Let's stick it on that type. And then when you press dot on that type, the factory will show up.
And so all I've done is put a static method in here now, okay? And inside an extension block that already, it's not a receiver parameter, it's, what are we calling it, like a receiver type?
Receiver type.
Yeah, maybe, but it's the type that you'll be able to come over here and say dot range.
So when you press dot on IEnumerable event, it now shows up because it's
Yeah.
a static extension method.
Absolutely. We can for each over that. And actually, let me put that in let's put this in I don't know, call it
variable?
X.
X
Is a great variable.
Very variable name.
Great variable name. I would recommend using it for anything.
Very descriptive.
Very descriptive.
Kinda
Yeah, and we'll just
says it all really.
write
Self-documenting code.
And so
right there.
I just want to prove to you that it does work.
Yeah.
So
Oh, you're running it
aha,
even?
there it is.
Did work.
It works. Stuff is real. I'm telling you, it's a release product. It's real this year, we swear.
So it, unlike the instance extension methods, we really didn't have to do anything to that static method. We just put it inside of that extension scope. But it's not like it had some extra state or something before, right?
Right.
It was already perfect as a static method.
And you can always disambiguate it, right?
Yeah.
Because you can just go to MyEnumerable and call it,
Yeah, so-
right?
but that
it's still
is-
there.
It is, yeah, that's the thing. It just is still there. So even when you do this, when you take a static method on a static class and turn it into an extension static method, it's still there on the static class as well. So you
Right.
can still disambiguate. So that's pretty good.
A couple of niggles though. Why do we need the source?
Yeah, we only actually have static extension members in that particular extension block. So we let you omit the parameter name when you don't need it.
Yeah, if you're mixing them, if we put them in the same block, if we had other methods, instance extension methods on IEnumerable event, source would be there and available for the instance methods to use, but the static method can't ever use it, right? So
Yeah, you can't use it, so you're allowed to omit it, and we do that here.
that's cool.
Yeah.
That's not exactly where I want to put it though, right? I mean, is it really all that discoverable in IEnumerable event?
Well, first of all, I feel like just doing it for int, that was kind of an underwhelming choice on Link's part, to be honest. Like, I would want ranges of many different things. I didn't have generic math back then.
Right, not until Tanner added it.
But we do
actually.
now. Thank you, Tanner.
Thank you.
And so, just for fun, let's go and actually generalize this a little bit.
So we could make this generic now. We could say, okay, it's an IEnumerable of t. It's going to return IEnumerable of t. We'll have to actually, to give it its starting number, it'll be a t. And of course, this doesn't build. There's no way to do that on t. But again, generic. This is the place where all the stuff that goes on the methods that are special in methods go, right? So we can put constraints, generic constraints on here. So I could say where t is an I number
Of t. And magically,
now I should be able to come over here.
can we, hang on. Do you know this? Do you know about I
hold on.
number of t? Do you know about generic math?
Yeah.
Look at that start plus plus down there just working.
Yeah.
Does it?
It does work. It,
Okay.
in fact,
yeah,
works.
it's a little small down there. I was looking,
You know
is
what?
there a squiggle? Is this?
It's no squiggle. Let
there's
me
no
actually,
squiggle.
you know what? I want to prove what we're looking at here. So I'm going to laboriously type a thing. We'll say, laboriously. I did say that. I set expectations. Get type, name, parens, and I will run this again, and we will see that in fact, yeah, there we go. Okay, so we're going to get that. But now I could change this to say long. Right?
That still works.
And This is, the one is an int, right? It's an int32, but it's a negative 2 billion to roughly, to positive 2 billion, and that's fully subsumed by long, which is, 64 bits.
It converts to long.
So it
is what you're
converts,
saying.
so it converts. So this should work.
Yeah.
And if I run that now, sure
Yeah,
enough,
sure,
they're
that
all
works.
longs. Well, that's cool.
And what about Ulong?
Oh yeah, sure, U-long, but that's not, it doesn't have a negative range, so that doesn't work. But I could make this
Yeah.
a uint32, and it'll work just fine.
And so, of course, generic math is cool, and you should be reminded of it because not enough people know how cool it is.
Yeah.
But also, we put it in here to have an excuse to show you that you can put constraints on those type parameters on the extension.
Yeah, it's still though, it's not that discoverable. I'm not going to think about IEnumerable of U-long to make a range. What I want is I just want it to be U-long, right? So I should just be able to say T there, right? And then I should be able to come in here and say U-long.range. And now we're into like discoverable territory.
Yeah, so there's nothing, now the code is obscure, yeah, there it is. There's nothing preventing you from using a type parameter as the receiver type. That's not illegal, that's totally accepted. If it's an unconstrained type parameter, you're being a little naughty because then every object in the universe will have that extension method.
Yeah, you're the bad engineer on the team that added that to display on everything.
As long as you constrain it to just Tanner's world, then it's fine. It's just numbers. So now, yeah, you can add that static extension method to any that any numeric type will just now have to give you a range of that type.
Anyone that implements INumber, which should be most of them.
So that shows you everything we have to show today about extension members. You can also, not shown here, static properties, also fine.
Yep.
Working on right now, operators. So extension operators is definitely planned, again, for Tanner. We call you out a lot.
He's really nice, and we do a lot of nice things for him.
And it's still an open question. If we're not showing them, we don't have the bits yet, if they make it into C#14, but definitely planned, extension operators. Think about that, adding plus to something else. Or plus equals.
All right.
And probably also other member kinds down the line. Shipping every year, you've seen this before, we will often do the core of a feature that is the most sought out, thinking ahead so that we now have this general syntactic scheme that we can add other member kinds, but they may only be there in a later release when we see that there's a demand or when we have the scenarios that'll help us make it just right, so we're not just guessing what it should look like, that kind of thing. So over the next couple of years, I would expect you to be able to see most kinds of function members, really. But we'll see where it goes. And keep us posted on what you use them for, where they kind of fall short, and those kinds of things.
So what do you guys think? Does this work? Yeah?
Yeah, okay.
All right.
Okay.
17 years it took. Yeah.
17 years, but not a day longer.
Yeah. That was a hard one, too. So, okay. Well, now we're switched over to C# Dev Kit.
We're even in dark mode. Just
so you know, these are the hot features. These are the ones that have not shipped yet. And we have a descending order, we're in descending order of confidence on how well we feel that they might make it into C#14, but they are in implementation at some state. And so we do want to talk about them and show them.
We can show, what we're showing is not coupled together prototype stuff for showing at build. It is the product implementation in a certain state of evolution.
I built a different branch, basically, and merged main in. That was it. It's fine. Okay. So
as I said, we're planning on having extension operators, but we don't quite have them yet. So instead, I just took and inherited from dictionary so that we can add more members, including operators, to them. That's kind of, don't do that at home, but
it's cute.
It's cute.
Yeah.
Think of these though as they could eventually be extension operators. Why am I talking about operators?
I don't know. We are adding a couple of new operator overloads for Tanner in the product. Tanner, leader of .NET.
Yes,
Tanner
the
Goodman.
the most powerful.
Most powerful figure.
Figure.
Just has great ideas and comes with needs, and we're happy to oblige on the language.
So yeah. So here's the thing, and we're going to have a maybe slightly silly example, but you know, the way you overload a compound operator like plus equals, like the ones with the equal at the end, the way you overload them today is indirectly. You overload the plus operator, and then plus equals works with that.
Yeah, it does like x equals plus, x equals x plus whatever's on the right, right?
Yeah.
But it uses that.
Yeah. But sometimes creating that result of the plus operator is pretty expensive because the thing you're adding is very big, like think matrices or multidimensional matrices called tensors. And you know, just producing that extra result can be quite expensive. And if all you're doing is like slapping it on top of the old one, deleting that one from the surface of the Earth, you know, maybe it was better to just mutate the old one to begin with and much cheaper. And so if we could overload the compound operators to do that, we could have more efficient implementations. And that's what this feature is about. So
you're going to have to help me because I do not remember how to type operator overload declarations ever. I look it up every time.
yeah, or ask Tanner.
I ask Tanner.
I will help you with this new syntax.
Okay.
So public
It's a good start.
void.
Oh, okay.
That took a turn.
That's different. I've never
Operator.
Okay.
That wasn't so surprising.
Suppose there's something missing.
Minus equals.
Okay. And then we're going to.
Let's do an enumerable of t key.
Okay.
And I call it keys.
Okay.
So what we're looking at here is an operator to remove a bunch of things from the dictionary by way of subtracting.
So I could. So we're just removing things. So I could implement
Yeah.
it by saying like, oh, you know, for each over the keys, and do like just whoops, wrong thing. Not remote.
Now, yeah.
There we go.
Okay, and let's first use it, and then talk about all the weirdness about it.
So we've got a thing up here, that does a remove. So we'll just use it here, and we're passing in an enumerable t key, so we can use a collection expression, which is not new. And there we go.
Yeah, but you could
adorable.
be like, it could be 5, 6, and so
Yeah,
like
you can put a bunch of these
It
in.
can be a list now because it's an enumerable. It's just using a collection expression. But coming back to the actual implement, or rather the signature there, many things are weird about this compared to the operator overloads you may know today and that you can kind of pretend that you remember the syntax for. First of all, it's not static.
That's so weird.
It is not static. And why is it not static? Well, you really want to mutate the receiver, right, the left-hand side. So why go to a bunch of trouble making it a parameter that you are then would have to be a ref parameter when it's a value type, because otherwise you couldn't mutate it and so on. Let's just use this, make it an instance operator. And you're just mutating the struct or object that is being called on.
So if this is a value type, then it would need to be a mutable value type, essentially, to work like that?
It would need to be mutable in order for you to be able to do something useful on it.
Yes, okay.
Yes. Because the intent is to mutate it. Right, so that's why it's void. And essentially, if you think about operator, you know, the old well-known static operator overloads, they're really like weird static methods with weird lookup rules, right? They're just like essentially static methods, but you look them up differently. And these are weird instance methods with weird lookup rules. So because they're essentially instance methods, you can do instance methods things with them. Like actually, you can make them virtual.
Oh boy.
We saw no reason to restrict that. So if you want that, you can absolutely do that.
You can go nuts.
You can go pretty nuts with that.
Yeah, that's pretty cool.
So that's how you do that. And we mentioned the kind of performance scenario, which is kind of the driving scenario for this. But also sometimes you want the compound operator, but you don't want the simple operator. You don't want, like, minus operator here might be a little weird. And I'm not saying that the minus equals isn't weird, but maybe it's a little less weird. And sometimes you want only that. And this gives you an ability to have that without also having the corresponding simple operator if you want. So
it's an adorable operator there. That's cute. That's very cute.
there you go. How many people, just out of curiosity, how many people in here ever use operator overloading in their code? That's pretty good. Okay, I think we did something good here.
I was expecting it started with 3 timid hands,
Yeah,
and
and
then
then
more
like, okay.
gained confidence.
Yeah, the others were like,
yeah.
okay, I can fess up to it as well.
Yeah.
Good.
Awesome.
Okay, that's a reason why. So that's that feature, right?
Yeah,
That's the
yeah.
reason why we are using dictionaries here in this example. That's because we want to talk about dictionary expressions.
Yes. We have a dictionary up here that's actually constructed with an object initializer. I'm gonna reformat it slightly.
Yeah.
Because it looks, I don't know, it looks a little odd to me. There should be a.
It irks you.
It irks me, and I don't like it. So I'm going to go ahead and wrap this initializer, so that because really this is an object initializer. It's with the index assignment stuff, so that you can assign into dictionaries. So it just calls. Essentially, it just sets the elements of a dictionary, rather than when you do the collection initializers where you double up the for dictionaries for the key value pairs.
Right.
That it winds up calling add, I think, right?
Yeah. How many people realized you could do this actually?
That was a cute little feature we had.
Yeah. It's
few
been around
releases
for a
ago.
while.
Yeah.
But
This is not new,
yeah, but
but it's new to most of you, and that's cool too.
that's cool.
Yeah.
But now we're gonna immediately make it somewhat obsolete.
Yeah, that's great.
So collections have collection expressions now. We've had them for a couple of releases.
We've got one right here.
Yeah, pretty cool, and we already got one up there. Why can't we do something like that for dictionaries as well?
Yeah. And so, and you can. So I'm going to go ahead and convert this. There's a nice fix for that. And this is a dictionary expression. Okay, so it's essentially, it's semantically very similar to what I just had, right?
Yeah.
Each of these are representative of key value pairs. Okay, so that colon there means that, you know, the left is the key and the right is the value. And that it's going to go through and it's going to call the indexes. It's going to do a set for each one of these into that dictionary. And now, actually, that I have it like that, now I kind of want to format it back, because this
Now it
looks
doesn't
better
irk-
like that.
Now it doesn't irk you anymore.
Doesn't irk me anymore. Yeah.
Code that doesn't irk Dustin, ladies and gentlemen.
Yes.
So
Only slightly below things Tanner requests.
yeah. So I'm gonna exactly. So I'm gonna, whenever Dustin goes like "Ugh," in the design meeting, we know, okay, we're not quite there yet. So I want to get into a few details of how this works. So dictionary expressions aren't actually technically a thing in C#. They're still collection expressions. It's just that there's a new kind of element that you can put in collection expressions that is this key value pair thing. So you can specify those in collection expressions. And if the target type has key value pairs as its element type, you're welcome to do that. When the target type also has an indexer, then it's a dictionary type. And then we use the indexer, or we do something similar when we put it in. Otherwise, we'll just call add if it's just a collection. Using the indexer has semantic impact, because it means that essentially dictionary expressions, we'll keep calling them that even though they're not technically a separate thing, dictionary expressions have last insertion wins semantics. Okay, so if you have the same key more than once, we don't throw, we don't keep the first one, the last one wins. And we try to make that consistent across all the different dictionary types that you might use this on. And luckily, all the ones that we just go through the indexer, they already tend to be consistent around that behavior.
So as he was saying, like adding this one in and putting the same key right here, this is fine. Because it's just going to set the previous one. It's not going to cause, you know, oh, this key already exists.
It's not fine, because one will have the value 42. But other than that, it's fine.
That's the answer.
That's the answer.
Yeah. But as you were saying, like anything that's kind of convertible to, like it's really a collection expression of key value pairs.
Yes.
Right. And so I can write this plus equals operator then, such that it takes an IEnumerable of key value pairs, right? And so then I can come over here and I can say, well, plus equals. Whoops. I can use the correct notation on my keys, and we could, you know, we could do this.
Tanner's the answer.
Tanner's the answer. And we could put a dictionary expression. So this one has a collection expression on the side, right, of just the keys, just strings. But this now has a dictionary expression on the side that gets turned into an IEnumerable of key value pair, and then inside we go ahead and we just set each one.
Yeah. So that is kind of how we just expanded collection expressions to also deal with dictionaries now, which many people have requested, and is probably the most common scenario we hadn't covered yet with collection expressions.
I will point out that it did technically come after, like, compound assignment operators, user-defined compound assignment operators. So our confidence is lower that it will appear in C# 14. That's we just want to make that really clear. But it is there, and it is coming.
Yeah.
So.
But one thing that was actually a little bit of an issue with collection expressions, but has become more to the forefront with dictionaries, is that sometimes when you create a dictionary, you want to say something extra, like particularly comparer. You want to specify a comparer for the keys that is not the standard one. And the collection expressions, they kind of lack the way for you to pass constructor arguments, like a comparer. And so we decided, alongside with dictionary expressions, we decided it's time for us to address that. And we struggled with the syntax a lot. I don't know.
I feel.
We're going to show you something that we decided on.
We did. We voted, and it was a decision.
We decided on it.
And we have never gone back on those ever.
It might not be the greatest syntax ever, but it's the best we could come up with.
Yep.
Okay. And it is to have a with element that has to go first. And in there, you can pass arguments essentially to the constructor. When I say essentially, that's because not all dictionaries are actually created by a constructor directly. You can, just like with other collection expressions, you can specify create methods. That's how you can build immutable dictionaries, for instance. Is that there's not actually, you can't add things in one by one to an immutable thing, and so there's another mechanism. But essentially, there's a way to pass extra arguments, such as a comparer. Why do you have a red squiggle?
The reason I have a red squiggle is because we're still using this My Dictionary. My Dictionary doesn't have that constructor.
Oh, you're right. Okay.
So we should point out that we've been using this silly type the whole time.
Yeah.
But if I just use dictionary,
then
you'd be much better, and then we can get rid of these because they don't have those operators. But
So of course the built-in dictionary class will support this. It has a constructor that takes a comparer, and you can use that. Another example, the other example I think that came up that was realistic is sometimes you're going to be adding a whole bunch more to a collection after you created it from the collection expressions. And so for things that have a capacity, sometimes you want to just pass in, actually make the capacity 100 because I'm just about to put a lot of stuff in programmatically.
Yeah, I'm going to put 4 in, and I'm going to put a bunch of other stuff in. And we don't want to pay for the growth.
Right.
Yeah.
But just like with other collection expressions, this is not limited to concrete classes. You could actually...
I'm going to remove this because I don't know if it works. Okay. But you can use them with interfaces, right?
Yeah. So
I can do iDictionary just like we can with collection expressions. You can do with iList, IEnumerable, and that you'll be able to do.
The compiler decides what to build. It will decide to build a dictionary for that one.
And like collection expressions, there will be a builder sort of mechanism that we provided for collection expressions that other collections could use that didn't have that obvious way to construct themselves. Like we did that for the immutable collections. I can't wait until this is available for Frozen Dictionary, just because it's a pain to create one. But yeah.
Cool. Yeah. So that is dictionary expressions and the argument passing thing for collection expressions. It probably has a name. I'm forgetting it right now.
Yeah.
And that is the wildest we're going to get today. And so we have about 6 minutes left for questions.
There's a mic right there in the middle. If anybody's interested in asking a question or getting anything about what we're doing here today, feel free, grab that mic and run, go for it. Or if you just want to take this opportunity to head out for the door.
You don't get to leave without applauding, guys.
Yes.
Hi. I'm Adson Dustin. Alec from New Jersey.
Hi, Alec.
Hi, Alec.
don't have a question. Just wanted to say thank you because you don't understand how many years I've been wanting to add datetime.min and max.
Okay.
Now I can.
Now you can.
Thank you.
Yep. Awesome. Everyone probably has a thing like that.
Well, you should really thank Tanner, but also Jared and Fred up here who, build this language
Yes.
as well. So like with their bare hands.
Another question, anyone?
Anyone?
They're just so hungry. Yes, go.
I'm wondering if you planning to add any kind of new data type that exists in Python but don't exist in C#.
New data type that exists. Well, as for data types, we should probably ask our library folks. I don't think that we have. Do we have anything concrete that you can think of? And did you have anything concrete in mind?
Like tuples, I think.
Well, we have tuples.
We have
Oh,
tuples.
you do? Oh, okay.
Yes.
We have the coolest tuples.
We have oodles of tuples.
Okay.
Our tuples
It's
can
been
have
a while that-
our tuples can have element names. Can the
And you
Python
can put,
tuples do that?
And you can,
Thank you. Great question.
yeah, and you can put extension methods on them.
Yeah. All right. Go ahead.
Thank you. I remember last time you covered the field keyword, you said there'd be some kind of warning if you used it that you could opt into, so that you could know that you were going to be encountering this breaking functionality going forward. Is that still in the plans?
The way we're planning it right now is that the warning you saw there is what we'll do. So essentially, when your code is such that it might have been broken, we will tell you. And then we give you fixes for it, and to restore that semantics. If you actually, I think the plan of record right now is if you actually meant the new thing, then you will have to either get rid of the thing called field that's in scope, if you can, change its name or something, or you really have to silence the warning there.
If for some reason you wanted the semantics to change so that you still had a field called field,
Yeah.
but you also wanted to use the field keyword in the property that previously referred to the field called
Yeah.
field, then you'd have to do something special.
I will acknowledge at some point we discussed giving you something that would essentially break you on upgrade, and we kind of moved away from that because people get touchy about being broken on upgrade, like getting a warning on upgrade. So we decided, okay, it's better to just have it in the language rather than some like bigger thing, like a project level thing.
Yeah.
Thank you.
A few years ago, sorry, I'm Alden. I'm from Portland, Oregon.
Oh, thanks. Hi, Al.
A few years ago, when I think it was Link coming out or something, people were saying that we should all move towards a lot of the new syntactic sugar because eventually the language is going to be written to be more efficient when you use the newer features. But it seems like we're doing lots of more checking, and when I look at like writing really efficient code, then people are taking away a lot of that checking and going back to kind of old ways of programming in a lot of cases. I was wondering if that's a trend that's going to keep happening, or kind of what your thoughts are on making the more complex stuff run more efficiently.
That's a really good question. And actually, if you go all the way back to LINQ, like language integrated query, we had half of it sort of right, where we did like high-level syntax and essentially said, leave it to the compiler, but the compiler didn't have the tools to do a very good job of making that efficient. And that's something we've taken to heart since then. So when we've done features that simplify your code or make it more elegant or readable, like pattern matching, collection expressions like we saw, records, we take great care that the code the compiler writes for you is as efficient or better than what you would have written yourself. You should see the code that implements pattern matching for like a switch expression is so complex because it really, really tries to reorder and to do things in the order that is most efficient in a way that would be very ugly to write at hand. So we actually think you can have your cake and eat it too when it comes to actually letting the compiler do the thing, letting the compiler select how the collection is built for a collection expression. It can do a much better job, and it can make it better release after release. If we find out we didn't do a good enough job, we can make the compiler better, and all of a sudden your code is better.
Yep.
So we try to combine those. There's also a little bit of in the old, like C# was always also focused on performance in that we had unsafe code, for instance. And we've tried to replace most of that with safe code by introducing spans, which are kind of a low-level construct but safe. And now people can write code that is very efficient, going to the lower level, writing it more in a more old-fashioned, tedious style maybe, but in places where they really need that extra performance. So that's how we try to think about that.
Thank you.
Thank you. I think we can have one more question. No more questions. Okay, I'm sorry.
We're at 20 seconds.
We're 20 seconds.
We got to say goodbye.
Okay, we will say goodbye, and then we will talk to you right after.
Yeah, come on up.
They might throw us out of the conference center, but if not, we'll hang around for a bit. Thank you all very much.